Study from Heinrich Heine University in Dusseldorf found that caffeine, at the concentration of 4 cups of coffee, moved a protective protein into your mitochondria, the tiny power plants inside every one of your cells. That sounds like good news. It's not. Because the way most Americans over 50 drink their morning coffee, the timing, the additives, the empty stomach, turns that same caffeine into a cortisol bomb that slowly strips your mitochondria of their ability to produce energy. And the damage is cumulative.
Here's what most people believe. Coffee is good for you, period.
They've seen the headlines. Coffee drinkers live longer. 3 cups a day lowers your risk of heart disease. And those studies are real. A meta-analysis published in the British Medical Journal in 2017, covering over 200 studies, did find associations between moderate coffee consumption and reduced mortality. So people drink their coffee first thing in the morning, on an empty stomach, often with sugar or flavored creamer, and they assume they're doing something healthy. They're wrong. Not because coffee itself is bad, but because the context in which you drink it determines whether it heals your mitochondria or damages them. Think of it like water. Water saves your life. But water poured into your car engine destroys it. Same substance. Completely different outcome based on where and when it arrives.
What most people don't realize is that your body has a built-in hormonal schedule.
Your cortisol, the stress hormone that gets you out of bed, peaks naturally between 6 and 9 a.m. It's called the cortisol awakening response. When you pour caffeine on top of that peak, you're not boosting your energy. You're flooding your system with a double stress signal. And here's where your mitochondria enter the story. Because cortisol, at sustained high levels, doesn't just make you feel wired. It physically changes how your mitochondria function. But the real question is how, and the answer sits inside a biological mechanism that most physicians never studied in medical school. Your body contains roughly 37 trillion cells, and inside nearly every single one of them sit mitochondria, anywhere from a few hundred to several thousand per cell. These are not decorative. They are your body's power generators. They take the food you eat, combine it with the oxygen you breathe, and produce a molecule called ATP, adenosine triphosphate. That's your fuel. Every heartbeat, every thought, every blink of your eyes runs on ATP. Here's the number that matters. A healthy adult produces roughly their own body weight in ATP every single day. If you weigh 160 pounds, your mitochondria manufacture approximately 160 pounds of ATP in 24 hours. That is not a typo. They do this by recycling each ATP molecule thousands of times. It's the most efficient chemical factory on Earth.
But here's the problem.
After age 60, your mitochondrial efficiency drops. A 2014 review published in Biomed Research International by researchers at the University of Padova found that aging is associated with reduced oxidative phosphorylation, the technical name for the process your mitochondria use to make ATP. Decreased ATP production, increased reactive oxygen species, the waste products your mitochondria produce when they malfunction. Think of a car engine running dirty. It still produces power, but it also produces more exhaust. And that exhaust damages the engine itself. Now picture your morning coffee. It's 6:30 a.m. Your cortisol is already surging, a natural spike that happens in every healthy human body. Your adrenal glands are pumping cortisol into your bloodstream to get you alert and functional. This is normal. This is designed.
Then you drink coffee. Caffeine stimulates your hypothalamic pituitary adrenocortical axis, the HPA axis. That's the chain of command that runs from your brain to your adrenal glands. A study by Dr. William Lovallo at the University of Oklahoma, published in Psychosomatic Medicine in 2005, tested 96 adults and found that caffeine significantly increases cortisol secretion, even in people who drink it daily. The research showed that tolerance to caffeine's cortisol effects is incomplete. Your afternoon cortisol levels remain elevated after repeated caffeine doses, even after 5 days of regular consumption. So here's what's happening inside your body at 6:30 a.m. Your natural cortisol is at its daily peak. Your caffeine is spiking cortisol further, and your mitochondria are sitting inside this chemical storm. Why does that matter?
Because cortisol is a glucocorticoid,
And glucocorticoids at chronically elevated levels physically alter your mitochondrial membranes. A landmark 2009 study from the National Institute of Mental Health, published in the Proceedings of the National Academy of Sciences by Dr. Jing Du and colleagues, demonstrated something remarkable. They found that glucocorticoids exert biphasic effects on mitochondria. Low levels of cortisol actually boost mitochondrial function. They enhance membrane potential, increase oxidative capacity, and improve calcium handling. But chronic high levels do the opposite. They decrease mitochondrial membrane potential, reduce oxidative capacity, and strip away a protective protein called BCL2 from your mitochondrial walls. BCL2 is your mitochondria's bodyguard. It prevents something called the permeability transition pore from opening, which is essentially the self-destruct button on a mitochondrion. When BCL2 levels drop in your mitochondria, those organelles become vulnerable to calcium overload, oxidative damage, and eventual cell death. But this is only half the story. What caffeine does to your adenosine system is even more troubling, and almost no one connects it to mitochondrial health. To understand the second hit, you need to understand how caffeine actually works. Because most people think caffeine gives them energy. It does not even a little. Caffeine is an adenosine receptor antagonist. That's it. That's its entire trick. Here's what that means in plain English. Your brain produces a molecule called adenosine throughout the day as a byproduct of burning ATP. Think of adenosine as a receipt. Every time your cells spend energy, they generate a receipt, and those receipts pile up. As they accumulate, they bind to receptors in your brain, specifically A1 and A2A receptors, and those receptors send the signal: you're tired, slow down, prepare for sleep. Caffeine is shaped almost identically to adenosine at the molecular level. So it sits in those receptors like a wrong key jammed into a lock. It doesn't open anything, it just blocks the real key from fitting. Your brain can't feel its own tiredness signal, so you feel alert. But the adenosine hasn't gone anywhere. It's still accumulating behind the blockade. And the moment caffeine wears off, roughly 5 to 6 hours later in a healthy adult, though the research suggests this half-life can extend significantly in people over 60 whose liver enzymes process caffeine more slowly, all that adenosine floods in at once. That's the crash. That afternoon fog at 2 p.m. that sends you back for a second cup. And here's where the mitochondrial damage compounds. Your brain adapts to chronic caffeine use. A 1984 study by Boulanger and colleagues, published in Neuroscience Letters, demonstrated that chronic caffeine consumption increases the number of adenosine receptors in the brain. The brain is trying to hear its own tiredness signal through the caffeine blockade, so it builds more antennas. This is called receptor upregulation. The result? You need more caffeine to feel the same effect. Depending on who you ask, this tolerance can develop in as little as 1 to 3 weeks of daily use. But here's what matters for your mitochondria. Adenosine isn't just a sleepiness molecule. It plays a direct role in mitochondrial signaling. Adenosine A2A receptors in particular are concentrated in your basal ganglia, the brain region governing movement, motivation, and habit formation. When those receptors are chronically blocked, the downstream signaling that supports mitochondrial biogenesis, the creation of new, healthy mitochondria, gets disrupted. If you've ever woken up at 5 a.m. already exhausted, before you've done anything, this is part of what's happening. Your mitochondria aren't regenerating overnight the way they should. Your adenosine system, rewired by years of caffeine overuse, isn't clearing properly during sleep. And the deep, slow-wave sleep your brain needs to flush waste and restore mitochondrial function, caffeine fragments it, even when you stop drinking coffee at noon. A 2024 study published in Nature's Scientific Reports by researchers at the University of Basel found that just 5 days of regular caffeine use reduced cerebral gray matter volume. The brain physically changed. Some scientists dispute the long-term significance of this finding, but the structural alteration itself was measurable. If this is making sense, and you want the third part, the part about what your body does with coffee at the chemical level that almost nobody discusses, subscribe now, because that section is next, and it reframes everything. Now here's the escalation. None of what I've described so far accounts for the single most damaging thing most coffee drinkers over 50 do every morning. And it has nothing to do with caffeine itself. What almost nobody talks about is the delivery system, not the caffeine, the coffee. Your morning cup doesn't just contain caffeine, it contains chlorogenic acids, diterpenes like cafestol and carweol,
and, depending on how it's made, significant amounts of acrylamide. Some of these compounds are protective. Coffee polyphenols are genuine antioxidants. The research on that is strong.
But here's the counterintuitive reality. The dose that helps your mitochondria and the dose that hurts them are closer together than you think. And the tipping point isn't just how much you drink. It's when you drink it, what you put in it, and what's in your stomach when it arrives. Let's start with timing. Your cortisol awakening response peaks roughly 30 to 45 minutes after you open your eyes. This has been measured repeatedly. One of the most cited studies on this is a 2005 paper by Fries, Dettenborn, and Kirschbaum at the Technical University of Dresden, analyzing data from over 20,000 cortisol samples. During this peak, your body is already flooding itself with glucose to power your morning. Your blood sugar is elevated. Your insulin is responding. Your mitochondria are running at high capacity to process this energy surge. Now add a cup of coffee with sugar or flavored creamer. What you've done is hit your system with a triple spike: cortisol, caffeine, and a glucose load, all within the first 60 minutes of waking. Your pancreas responds with an insulin surge. That insulin drives glucose into your cells faster than your mitochondria can process it. The overflow generates reactive oxygen species, free radicals, inside your mitochondria. And those free radicals damage the very machinery that produces your energy. This isn't theory, this is measurable chemistry. It happens every morning in approximately 150 million American adults who drink coffee before breakfast. Read that again. Your mitochondria are being damaged not by poison, but by poor timing and sugar. Now here's the part that brings this together. A review published in the International Journal of Molecular Sciences in 2022 examined caffeine's dose-dependent relationship with oxidative stress. At moderate doses, roughly equivalent to 1 to 2 cups of black coffee, caffeine acts as an antioxidant. It scavenges free radicals. It protects cell membranes. But at higher doses, particularly when combined with glucose and cortisol elevation, the balance tips. Reactive oxygen species overwhelm your mitochondrial defenses. The electron transport chain, the assembly line inside your mitochondria that produces ATP, starts leaking electrons. Those leaked electrons react with oxygen to create superoxide radicals. And superoxide, over time, damages mitochondrial DNA. Here's why that matters specifically for people over 50. Your mitochondria have their own DNA, separate from the DNA in your cell nucleus. And mitochondrial DNA has almost no repair mechanism. When it's damaged, it stays damaged. And damaged mitochondria don't just produce less ATP. They produce more waste, more inflammation, more oxidative stress. It's a self-accelerating cycle. The research is still evolving on this, but some researchers now believe that this mitochondrial damage cascade is one of the primary drivers of what we experience as aging itself. Not just wrinkles and gray hair, but the deep fatigue, the brain fog, the loss of muscular endurance that people over 60 attribute to just getting old. So the question becomes, if your morning coffee habit is contributing to this cycle, how do you change it without giving up coffee entirely? Here's a specific step-by-step protocol backed by the mechanisms we've covered. Not a fad, not a trend, a strategy based on how your body actually works. Step 1. Delay your first cup by 90 to 120 minutes after waking. This allows your cortisol awakening response to peak and begin its natural decline before you add caffeine. Dr. Andrew Huberman at Stanford's Department of Neurobiology has recommended this publicly based on the cortisol timing research. The goal is simple. Stop stacking caffeine on top of your highest cortisol. Let your body's own alertness system work first. This alone reduces the double cortisol spike that stresses your mitochondria. Step 2. Drink your coffee black, or as close to it as possible. Every gram of sugar you add forces your mitochondria to process an additional glucose hit during your morning cortisol window. If you need flavor, consider a small amount of cinnamon, which some preliminary research at the Human Nutrition Research Center in Beltsville, Maryland, suggests may actually improve insulin sensitivity, or unsweetened almond milk. The mechanism is straightforward. Less glucose in your system during peak cortisol means fewer reactive oxygen species inside your mitochondria. Step 3. Eat something first. Even a small protein-based meal,
2 eggs, a handful of almonds, a piece of cheese, before your coffee slows caffeine absorption, blunts the cortisol spike, and gives your mitochondria a steady fuel source instead of a sharp glucose surge. This isn't complicated, it's buffering. You're giving your system a foundation before you stimulate it. Step 4. Set a caffeine curfew. No coffee after 1 p.m. Caffeine has a half-life of 5 to 6 hours in most adults, but in people over 60, liver enzyme activity, specifically the CYP1A2 pathway that metabolizes caffeine, slows down. Your half-life may be closer to 7 or 8 hours. That means a 2 p.m. coffee still has significant caffeine in your bloodstream at 10 p.m. And even if you fall asleep, your slow-wave sleep, the deep restorative phase where your mitochondria undergo repair, gets fragmented. Step 5. Cycle off for 7 to 14 days every 3 months. This allows your adenosine receptors to downregulate back to baseline. The brain doesn't need more antennas if there's no signal blocker. Your natural sensitivity to caffeine returns. Your sleep deepens. Your mitochondria get the overnight repair window they've been missing. Dr. Peter Attia, physician and longevity researcher, has discussed caffeine cycling as a tool for maintaining drug sensitivity and protecting sleep architecture in adults over 50. The principle is simple. Chronic, unbroken exposure creates tolerance. Periodic withdrawal restores sensitivity. If even one of these steps was new to you, hit like. It tells the algorithm to show this to more people who need to hear it. Here's the larger truth nobody wants to sit with. Your morning coffee ritual, the smell, the warmth, the first sip, isn't the problem. The problem is that ritual became automatic, unconscious. You stopped asking whether it was serving your body and started assuming it was. And your mitochondria paid the price. Not in one dramatic failure, but in 10,000 tiny moments of excess cortisol, excess sugar, mistimed caffeine, and fragmented sleep, each one too small to notice, but together enough to erode the energy system that keeps you alive. The good news is your mitochondria are not permanently broken. They can regenerate. Your body can build new ones through a process called mitochondrial biogenesis, triggered by exercise, fasting, deep sleep, and yes, even properly timed coffee. The same molecule that damages them under the wrong conditions supports them under the right ones. That's not irony, that's biology. Context determines chemistry. Historians still argue whether coffee is humanity's greatest stimulant or its most widespread drug dependency. The honest answer is probably both. But now you understand something most people never will, that it's not what you drink, it's when your cells encounter it that decides whether it helps or harms. I want to hear from you. Drop a comment below. When do you drink your first cup of coffee? And are you going to change that after watching this? I'd bet most of you reading this have felt that 2 p.m. crash for years and never connected it to your mitochondria. Here's the line I want you to carry out of this. Your mitochondria don't care about your habits. They care about your chemistry. Share this with someone who drinks coffee first thing every morning. They need to see this. And if you haven't subscribed yet, you should. What's coming next week covers the single worst food most Americans over 50 eat at breakfast, and what it does to your brain within 90 minutes of consumption. I've been researching it for months. Your energy was never supposed to fade this fast. Now you know why it did and what to do about it.